Alright, so welcome to Unit 5. This unit is all about transformations. So, starting off, we're going to look at congruence transformations. So our warm-up for today says to name two congruent segments. So, here, if angle 1 is congruent to angle 2, sorry. So angle 1 and angle 2 being congruent, mean that the sides opposite of them are congruent, which means that VW is congruent to UW. So UW, or VW, is congruent to UW. Name two congruent angles if RS is congruent to RT. So same thing applies here, but now we're looking at the converse. So RS being congruent to RT means that the angles opposite are congruent, angle T and angle S. So angle T is congruent to angle S. And the last one, we want to find the measure of angle R if the measure of angle RUV is 65. So let me go erase all this here real quick. Angle R is up here at the top, and angle RUV is 65. It's marked as congruent to angle RVU, which means that RVU is also 65. So now we just need to add those together, subtract from 180, and we'll have what angle R is. So 65 plus 65 gets us 130, and 180 minus 130 is 50. So the measure of angle R is 50. Alright, so we've been doing these review cahoots all week, and we've also done a quiz that my A-Day students are doing today. But, B-Day kids, you guys have already seen these notes. So, vocab for this unit. We have not done the vocab yet. We will do that starting this week on the second day of the unit. The reason for that is because we have had so much to do with the quiz and all that. So, really? Hold on. Anyway, besides all that, here's our vocab for today's notes. Transformation, pre-image, image, congruence transformation, isometry, reflection, translation, and rotation. So first off, the three main types of transformations: reflections, translations, and rotations. There is one other type that we'll look at later, but these are the three types of transformations that are congruence transformations. So a reflection or flip is a transformation over a line called the line of reflection. Each point of the pre-image and its image are the same distance from the line of reflection. A translation or slide is a transformation that moves all points of the original figure the same distance and in the same direction. And a rotation or turn is a transformation around a fixed point called the center of rotation through a specific angle and in a specific direction, clockwise or counterclockwise. Each point of the original figure and its image are the same distance from the center of rotation. So, first off, all we're doing today is just identifying these things. So here we have two figures. They look the same. They are pointing the same direction. And so pointing the same direction pretty much eliminates a rotation. They are not lined up in the same position on either side of a line, so that eliminates reflections. If you notice, so since they pretty much are moving in the exact same direction, all the points are really to 100% sure know what type of transformation this is, would be use those dotted lines and find the slope to make sure. Now we can tell, since we do have the images, that they are the same figure, they are congruent, and since they are pointing the same direction, that kind of leads us to either a reflection or translation. And if we use these dotted lines, find the slope of those dotted lines, as long as they're the same, then we know that it is just a translation. So, using that, we go up 2 over 1, 2, 3, 4, 5, and hopefully the same thing for this other point. 1, 2 over 1, 2, 3, 4, 5. So there are the same slope for those two dotted lines, which means that this for sure is a translation. Now this next one, same exact question, but different picture. So if we look here, it's definitely not pointing the same direction anymore, which means it's either a reflection or a rotation. So translation is out. We also know that it is the same distance away from one point, and it doesn't look the same as far as if you were looking through a mirror, right? Or if not through a mirror, but in a mirror. So notice too that the bottom corner is pointing at the same point, which means that is a center of rotation. A reflection is across the line. A rotation is around a point. Translation follows a line. So this is for sure a rotation. Last one here, you can see that it is not rotated. Our points are not pointing at the same point. Not all of them anyway. And it is definitely not facing the same direction. So since it's not facing the same direction, it's not a translation. And again, the points are not the same distance away from another point. So it's not a rotation. This has to be a reflection. And it is a reflection across the x-axis. So, our next one here, once again, we need to identify the type of congruence. This is a bridge over water. Hopefully you know that the water is going to be reflecting the image. So this is, again, a reflection. Now, this next one, we have two triangles. They are pointing the same direction, so that kind of lends us to think that this is going to be a translation. So we want to identify the type, and we want to verify that they are congruent. Now, there's a few ways we could do that. Since we are given the picture, we can actually just find the slope of everything and make sure that the slopes have a pair to match up. We could find the slope between the lines, and we can find the slope of the points that should have moved. So J to P, K to Q, L to R. So we can do all of that as well. And they should all be congruent too. So let's do that. So from J to P, our slope is up 1, 2 over 1, 2, 3, 4, 5, 6. So it's 2 over 6, which simplifies to 1/3. Same thing for K, hopefully, to Q. 1, 2, good so far. 1, 2, 3, 4, 5, 6. We got our 2 over 6, so that is K to Q. It's 2 over 6, or 1/3 again. And then we're going to look at L to R. So L goes up 1, 2 to be even with R. 1, 2, 3, 4, 5, 6. So we do have our 2 over 6, or 1/3. So we have our vector being correct, which is something we'll get into a little bit more later. So we know that they translated the same distance, so it is translation for sure. Now we just need to make sure that they have the same slope. That means they are congruent. because that will matter as well. They look like they are, but looking and being are two different things. So, first off, slope for kj. Slope for kj is up 1, 2, 3, 4, 5 over 1, so it's just a slope of 5. And that means that QP needs to be the same thing. So we go up 1, 2, 3, 4, 5 over 1. 5 over 1 is 5. So we're good there. Well, let's look at J to L, or L to J. So JL and PR. These need to be the same as well. So L to J goes up 1, 2, 3, 4 over to the left -1. And R to P, 1, 2, 3, 4 to the left -1. So far so good. We have a -4, -4 for those two. Then our last pair is just going to be KL and QR. Believe it or not, what I'm doing is actually a lot less work than what we really need to do. If we weren't given the images, we would have to find the distance between the points and find the slopes between the points to make sure that the slope is the same and the distance between the points is the same. That's a lot more work. We're not going to do that. So I'd have to do distance formula 6 times and a slope 6 times without the graph. So having the graph definitely makes this problem a lot easier. All right, so K to L up 1 over 2. So that's 1/2. And QR up 1 over 2. 1 over 2, 1/2. So we got our 1/2s, we got our -4s, we got our 5s. Everything is good. This is a translation for sure. And it is indeed a congruence transformation. So we identified the type of transformation. That's what we did with all the slopes, or all the transformation vector lines, the 1/3, and then we verified congruence, checking the slope of all sides, make sure that they match. All right, so that is it for these notes. We did do vocab when we did this. We did not have time for B-Day to do it, but A-Day will. And here's your exit ticket.